Thank you, Steve, and thank you again to Angela and Andrea for presenting this morning and sharing your perspective on Florida's unique water challenges and providing some great examples of the need for interdisciplinary collaboration and research at our universities and research institutions. Next, we're going to move into the introductions phase of the program, where our 30 presenters will have an opportunity to talk a little bit about themselves and their research interests using those research profile slides as a guide. Each presenter will have 3 minutes to introduce themselves. You may notice at the bottom right of this screen, there's a green bar that is steadily moving towards the right side of the screen. That is the automatic timer. So when that green bar reaches the far right, your time is up and the slide will advance automatically. So fair warning to everyone, we will mute you when you get to your 3 minutes to allow the next person to begin their presentation. In between each slide, there is a 5-second transition slide that will display the name of the next presenter, which is also at the bottom right of each profile slide. If anyone is absent, we're going to leave their slide up for about a minute so people get a chance to read it, and then we'll skip on to the next presenter. With just a couple of exceptions, these slides are all in alphabetical order by first name, so you get a sense of kind of where you are within that overall order. And then, of course, please remain muted until and unless you are actively presenting. And if you have any issues, questions, concerns, message either me or Carolyn in the chat. So our first presenter is Trisha Kaisar from the University of Florida. Trisha, please go ahead whenever you are ready.
Hi, good morning. Thank you so much for kindly allowing me to go right away. I'm also presenting at the GTM State of the Reserve in just about an hour, so I appreciate your flexibility. I'm Dr. Trisha Kaiser with the University of Florida and Wildwood Consulting. My work revolves around the application of GIS and spatial analytics to water quality parameters, especially as has been influenced by anthropogenic impacts. My projects have included developing a weighted multi-criteria vulnerability assessment method to quantify the vulnerability of septic systems to climate change related impacts, not to assess water bodies that might be vulnerable to septic system issues. I've also using the NOAA CCAP data, calculating the land cover and population changes across the southeastern United States to understand how land cover has changed as populations have changed, usually increased, and how that's also affected surface waters as well as oyster reefs, which are very key to processing water quality. I've also worked on analyzing water quality parameters across different scales of development and see how that has influenced some of those important parameters, nitrogen, phosphorus, and fecal indicator bacteria. I usually work with raw data sets. My work is data-based, it's not field work. So I'll get those raw data sets and clean them up and merge them all together and kind of spin them around and do lots of fun stuff. And again, this is spatially based, so I work with GIS. I also work with some different programming languages, Python, R, and SAS, and have a lot of fun being a data geek. Thank you.
Hi, my name is Woo. Hi, my name is Woo Young Lee. I am associate professor at UCF and in the Department of Civil, Environmental, and Construction Engineering. I would like to thank this opportunity. I have been working on the smart water and wastewater treatment and management with the two main research directions. So the one is the electrochemical sensors for the water quality monitoring, such as heavy metal and also nutrients such as phosphate monitoring. And the second is the renewable energy productions, such as green algae biomass, electricity, and hydrogen gas production from the waste. I also have been working on the nitrification and also corrosion in the drinking water distribution systems. My research in Florida and water is that we recently developed the cyanotoxin detection sensor in the lab, and then that can be used for the toxic blue-green algal blooms. And also, as you know, there are like a PFAS contamination in water and groundwater is one of the very important problems in these days. And we just published a research paper with an innovative technology of electrochemical reduction remediation of the PFAS in water. And like the past years, I have been working with the OUC to grow the green algae using flue gas in the Staten Energy Center. And we also developed a new system to produce a hydrogen and also the electricity using MFC and also the microbial electrolysis cell technology. And also water toxicity sensor for drinking water and groundwater monitoring, as well as agricultural irrigation such as lead, arsenic, and also mercury, cadmium, other contaminants such as phosphate and also nitrogen is one of my interests. Actually, currently we are developing one NSF proposal for the soil monitoring in agricultural application. And also gray water and black water reuse is the current ongoing SBIR project with like a local company. And we also developed a new nanotechnology for separating, absorbing oil from oil spill event. I can help to develop the research idea and also research collaborations. So I'm looking forward to more research collaboration opportunities and with the researchers and stakeholders in Florida. And thank you very much for your time. And thank you again.
Hi, my name is Abuzar Kobir. I'm an associate professor in the Department of Chemistry at Florida International University. And I do have a diversified research interest. So from water quality monitoring to environmental pollution remediation, and also standalone paper-based colorimetric sensors. So I have been very successful in developing many technologies. I do have around 20 patents in the United States, and most of them are based on water quality monitoring, chromatographic, sample preparation, separation, and the like. So recently I have developed a new colorimetric sensor to monitor urea fertilizer in wastewater. So you just dip in the sensor, and by looking the color change, you would know basically whether you do have any residual urea or in the water or not. And also one of my research is creating molecularly imprinted polymer. So I do have invented a new technology that allows anyone to create molecularly imprinted polymer using one or multiple templates that can allow you to monitor any compounds of interest from any type of sample matrices, biological fluid, environmental water, and any complicated matrix. So I'm always open to research collaboration. And in fact, we do have collaboration across the world. Many European countries, Asian countries, I do have research collaboration. I have published more than 100 peer-reviewed papers in high impact journals, and we are continuously looking for new collaboration. And I'm very excited to join this Florida water quality collaboration, and I would definitely look forward to working more closely in future. And you all are welcome to contact me and to basically join the joint research projects. Thank you very much.
Hello, everyone. Ali Ibrahimian, an assistant professor at Civil and Environmental Engineering Department at FIU. So my background is in civil engineering with a focus on water resources engineering and management. I have, in general, two main research areas. The first one is urban hydrology, stormwater management, and with a specific focus on green stormwater infrastructure. And the second area is multi-criteria decision analysis and multi-criteria socio-technical risk analysis. So under my first area, which is urban hydrology, I do field work using different sensors for soil and water problems. I do field monitoring of green stormwater infrastructure, and then I use those data and to develop knowledge and information for understanding the dynamics of hydrologic processes in green stormwater infrastructure. And again, using those data and information for dynamic modeling and improving the design of green stormwater infrastructure. Currently, I'm trying to understand how we can use these green stormwater infrastructure in coastal areas because of, several problems which are specific to some coastal areas, usually shallow groundwater level, effective sea level rise. So there's a knowledge gap in this regard. And that's the area that I'm currently working on. And under my second area, which is multi-criteria risk analysis and decision making, I've used this area in different applications. And currently what I'm doing is trying to incorporating social and environmental criteria into infrastructure planning. So I'm working on a couple projects, for example, integrated flood and social environmental risk analysis and some road and bridge networks. And I'm more than happy to collaborate with those of you who are working in related areas. And I'll give you some time to read my slide. Thank you.
So it looks like this presenter is not among the participants. We might want to carry over to the next presenter.
We're just going to leave it up on screen for a minute for folks to read it and take down any notes to follow up later.
Good morning, everyone. So I'm finally with the presenters available. So yeah, so thanks for organizing this event. It's very useful to learn about everyone's work. I'm Dr. Ibrahim Ahmed Sharaf, a senior research associate in the FSU College of Engineering, with the Civil and Environmental Engineering, also the Ryder Center, Resilient Infrastructure and Disaster Response Center. So I have two main focuses. One is predicting floods to support design of water infrastructure, so dams, levees, spillway, culverts. And the other is surface water pollution prediction to support decisions related to pollution reduction measures by implementing green infrastructures, best management practices. And there's a theme of deep uncertainty, including the impact of climate and land cover change, as well as sea level rise on both floods and surface water pollution. So I work a lot on water prediction, and I collaborate with a lot of disciplines that are affected, including public health scientists, social scientists, economists, and I can help definitely with the predictions, quantification of the impacts of flood and surface water pollutions. And I would love to hear about collaboration opportunities. I've collaborated a lot in the past. I have a few projects currently. One is funded by the NSF on the impact of Hurricane Ida, and more broadly, floods, like major floods on public health, especially the respiratory health of human. This in collaboration with Harvard School of Public Health. And I have a project for the Center of Florida, St. Lucie Estuary and River Basin, funded by the EPA for water quality analysis using data-driven techniques such as machine learning. And this is, we have a large group of technical advisory board from state, federal agencies, local government, also extension agents to help us having an impactful science there. And it's a 3-year project just started. We also have a project together with Dr. Alamdar here from the Everglades Foundation for updating the climate change scenarios using CMIP 6 scenarios in collaboration with Dr. Manlent in the Everglades Foundation. I also have a few unfunded efforts. One is on the ACF basin and updating operation of the reservoirs. The other is the impact of urban irrigation on the hydrologic cycle on the local scale and the flood dynamics. So with that, I turn it over to the Jason Evans, and thanks again for organizing this.
Hello, everyone. I'm Lei. I'm professor at the University of Central Florida, Department of Chemistry and the Nanoscience Technology Center. But compared with a lot of background or expertise here in water treatment, our expertise are in the more towards the material development for the water treatment. So we are the material synthesis and the characterization group, but we have worked with a lot of professors at the university, like Woo-Young Lee, Dr. Lee just did his presentation, moment ago, and Anwan Sadmani and Linda Waters. So we are focusing on using our new material like the fibers, membranes, catalyst to kind of remove the pollutants in water, to absorbing heavy metals, and also even the monitor the microplastics in the in water. We had a project with the Heckley Center and also DOE, and recently the Wildlife and Spring Foundation of Florida. So what we can provide are the system that can be used for water treatment, and also catalysis, and even some kind of mechanistic studies. And what we need is basically like a simulation, regarding the water treatment, or larger scale. When I heard a lot of presentation here, it's not about like 100 millimeter, it's about hundreds of acres. So we want to work with you guys to really push what we have to real applications. So in summary, we are interested in detecting and removing heavy metals, and also we are working with Dr. Lee regarding removing those perform-related compounds, any other organic pollutants, and also a hot topic right now, microplastics. Thank you.
Hello, everyone. Can you hear me first? Mike, can you confirm that?
Yes.
Okay, good. So I am Nasrin Alamdari, Assistant Professor at Florida State University, and I'm part of the Resilience Infrastructure and Disaster Center. My research expertise is in climate change and sea level rise impacts on hydrology and water quality. Also, the role of natural and nature-based features in mitigating short and long-term impacts of climate change and sea level rise, urban hydrology, urban stormwater management and green infrastructure, and also socioeconomic, like co-benefits of green infrastructure, like socioeconomic and cost benefits of green infrastructure. I'm always interested in collaborating with different people. I've also made a lot of collaborations, and I have some projects. The first one is funded by Florida Department of Environmental Protection. We are developing statewide decision support tool to control nutrients in urban communities using stormwater green infrastructure. And then I have one EPA project to predict and mitigate harmful algal blooms in Biscayne Bay using advanced numerical methods such as machine learning algorithms. The next project, I think Dr. Ahmadi Sharif also mentioned that we're collaborating with Dr. Thomas Downland. And this fund is funded by Everglades Foundation to project climate variables using the recent CIMIC 6 data in Everglades to develop a new set of rainfall identifies potential evaporation estimates, flows, and irrigation demands compatible with South Florida water management model. And then I have another project with Oak Ridge to detail the socioeconomic and environmental benefits of green infrastructure in underserved communities, to come up with like how green infrastructure would be beneficial for the health, like waterborne disease, vector-borne disease, and water toxins, and then how much these green infrastructure are beneficial in reducing pollutants like coliform bacteria, and then we can develop an index that how we can distribute this green infrastructure in different communities across Florida, especially for underserved communities. And the last project that I have is from FDP again, that we are developing a curriculum for schools, for teachers and students for sustainable stormwater management and green infrastructure to ignite their interest. So these are a couple of projects that I have. I'm always interested in collaborating with different people, different areas, social scientists, economists, hydrologists, and ecologists. With that said, this was my presentation. And if you have any questions, so I think I have my email address and everything. I would be happy to discuss my projects further and also future collaboration opportunities.
Hi. Good morning, everyone. I'm Nibin Chen. I'm a professor with UCF. My current work mainly concentrates on the innovative development of different green substrate media for filtration of nitrogen, phosphorus, bacteria, BOD, and etc. So that has been applied to different scales, from lab scale to applied scale and to field scale campaign through several different pilot studies around the state. In the past 10 more years, I have extended those innovative media to deal with different pollutant of interest. The current project I'm working on, funded by FDP, is to remove ergotoxins such as microcystin and even PFAS in St. Lucie River basins. So these filtration media has been applied to different low-impact development technologies, including stormwater detention, retention pond, green roofs, bioswales, and even the septic tank systems for wastewater treatment. So the main purpose of this series of innovation is to provide a cost-effective, scalable, and applicable media with cost effectiveness in order to reduce the implementation burdens. My current media has about 1/10 in price relative compared to those available media in the market. So that's the basic effort for nutrient removal and ergo bloom removal in my research work. Another track of my research is about the remote sensing. I've been using satellite remote sensing to monitor the eutrophication status in Tampa Bay, the Great Lake region, and many other water bodies around the globe. So that is a kind of complementary techniques to echo the filtration media research at the infrastructure levels to understand how those infrastructure of the filtration media can achieve. So the current effort has been doing something with different scale, from urban scale to regional scale. With this, thank you for your attention.
Hi, everyone, and thanks to the presenters for organizing. I'm Noelle Bouquet. I am at Eckerd College in St. Petersburg, Florida, obviously Florida. I am a social scientist. Specifically, I'm a human geographer, so I'm interested in the relationships that develop between particular people and the environments that they're in. One of my interests is in how public infrastructures and well-being are interrelated. So my more recent research has focused on urban fishing and to what extent people are relying on urban fishing for food, how that intersects with food security questions, and how people fishing from shore are affected by water quality and water access issues. So my most recent work has found so far, at least in the Tampa Bay area, that about 20% of people fishing from shore are actually meet the federal definition for food insecure. So many people are fairly vulnerable, but shore fishing is a really diverse, and urban fishing is a really diverse pursuit. We've found a huge range of economic status and racial diversity as well. So they're really interesting spaces to study. But one of the things that we found is that a lot of urban fishers are very concerned about water quality. And so I would, love to collaborate with someone who's working in, investigating microplastics contamination, going beyond heavy metals if fish are carrying in these urban areas, if they're carrying drug residues or, other types of environmental contaminants would be really wonderful to know. And of course, if anyone's working on red tide issues, love to collaborate around that too, as that's one of the central concerns of urban fishers as well. Yeah, I'll just give you a minute to read my slide, and thanks for your attention.
Hello, everyone. Thank you, everyone, for being here today. My name is Paloma Carpon de Gramont, and I am a research coordinator of the Water Institute at the University of Florida. I'm not a faculty, but I am here to talk about a little bit the work that we do at the Water Institute. So in my role, I support the Water Institute mission of building a diverse community that conducts interdisciplinary research, education, and outreach to understand and solve complex water issues. We do that by three main goals. One is to actually increase the number and diversity of faculty and collaborators we work with. So this is the reason why I'm here today. We also bring together teams to produce high quality interdisciplinary water research and education programs to address state, national, and international water issues. We work with 300 faculty for over 65 affiliated departments at the University of Florida, but also with people outside the university. And I'm just going to briefly talk about the program that we have. So one of our main programs is this idea of building interdisciplinary research programs. So we convene teams to research, develop, and encourage the implementation of new science, technology, and policy solutions. And so as an example, one of our projects, which is called the Florida Facets, the Florida Aquifer Collaborative Engagement for Sustainability, that is funded by the USDA, aims to understand the changes needed to maintain a robust agricultural and silvicultural economy while protecting the water quality and quantity of the Floridan aquifer and its springs and rivers. So basically, we're trying to understand the impacts of different BMPs on water quality, quantity, and yields. We also have a NASA-funded project where we are trying to increase the regional relevance and usability of climate and sea level rise models for specific needs of water suppliers and resource managers in Florida. One of the other things that we do is to build scientist stakeholders, communities of practice. And so one of these communities that we have been coordinating for 10 years is the Florida Water and Climate Alliance that hosts webinars. And so we are always trying to identify speakers for these webinars. And finally, I want to talk just for networking opportunities, waters, including researchers, policymakers, water managers, industry students. So we invite you to join us in 2 years in this symposium, and I think that's where I'm going to be. Thank you so much.
Good morning, everybody. Thank you all for organizing this. I think I'm finding this to be extremely useful. My name is Chris Wilson. I'm a professor in the Soil and Water Sciences Department at the University of Florida. My program is focused primarily on environmental chemistry and toxicology, and specifically organic chemistry. Our research focuses on 4 different areas. We have a lot of research focusing on the fate of organic contaminants in the aquatic environment. We also conduct exposure assessments for environmental resources, both aquatic environment as well as the terrestrial. We also have a line of research looking at the effects or establishing effects assessments for terrestrial and aquatic organisms. We have a azenic culture of limna minor that we've maintained for about the last 16 years, and that's one of our favorite toxicity testing organisms that we work with. And then lastly, we do a lot of research focused on bioremediation of inorganic and organic contaminants. Currently, we have research focusing on minimizing the contamination of nectar in ornamental plant production processes. So we're also focusing on other floral resources, so pollen, corollas, as well as leaves. We have just started a study characterizing pesticide and pharmaceutical exposures in local water bodies within Alachua County and some of the surrounding springs. And hopefully data generated from this project will feed into projects developing BMPs as well as evaluating effects depending on what we find. And then we're also just setting up some harmful algal bloom toxin research. So developing the analytical methods for several of the microcystins and establishing some cultures that we can work with. We also do quite a bit of PFAS targeted analysis for colleagues, working with leaching in the environment as well as trophic transfer type experiments. So our lab is really well equipped with fairly late model analytical equipment, and we're always looking for opportunities to engage with other faculty and researchers in the state of Florida. So that's all. Thank you.
Hi, how's it going? My name's Patrick Musgrave. I'm an assistant professor at the University of Florida in the Mechanical and Aerospace Engineering Department. Unfortunately, my camera isn't working right at this moment, but so my research primarily focuses on underwater robotics. So in particular, I'm interested in any time where you have fluids and structures interacting with each other. So soft robotics, bio-inspired underwater propulsion, and then how you can use those types of systems for novel sensing types of applications. And so in particular, some of my main work is on that bio-inspired autonomous underwater vehicles, so sort of robotic fish. So we're interested in designing novel methods to actually create these systems. And so in general, autonomous underwater vehicles are useful for remote sensing. So capturing, salinity, algae bloom, concentration, turbidity, any type of other sensing modality in, Florida's water systems. So whether that's off the coast or in the coastal or estuaries. And then applying bio-inspired autonomous vehicles, basically now you can use these types of autonomous systems for sensing, but you gain the benefits of these bio-inspired systems. So, these bio-inspired robots can operate better in coastal areas and near vegetation, so they can operate without getting caught in the actual vegetation itself, near wildlife. And then they also just don't kick up as much dirt and cause as much turbidity in the water. So it offers a little bit better opportunity for some of that sensing. And so in particular, I'm interested in finding out applications where we can apply these types of bio-inspired autonomous robotic systems. So if you have novel sensing environments where you're trying to collect data, where there's sort of a lack of existing data and mapping capability, and then based on those types of sensing challenges, what types of sensors you use and where you could see some potential benefit. And then more general, my work focuses on underwater robotic systems. So helping to design these types of underwater systems where you have some type of soft or compliant structure. And that could even including modeling some type of underwater vegetation. So, flexible plant matter, things like that. So feel free to reach out, visit my website, send me an email. I'm happy to collaborate and looking for, any novel challenges you may have. Thank you.
Do I wait until it's over? Yeah. Wonderful. Good morning, everybody. My name is Peter Hasenberg. I'm currently a senior research scientist at FIU. Actually, I joined FIU fairly recent, last October, where I'm leading right now what they call the modeling and GIS team. As you might hear from my beautiful accent, I'm not from the US. I'm originally from the Netherlands. Before this, I was a senior scientist at the Dutch research company Deltares. Before that, I was about 8 years at the University of Arizona, both as a postdoc and an assistant professor. My background ranges from hydrology, hydrometeorology to climate change, a lot of modeling and a lot of data, obtaining data in the field, but all around the theme of water. Currently, our team at FIU mainly does research for the US Department of Energy, where we focus our work on the former nuclear research site throughout the US, and where we apply, on the one hand, joint hydrological biogeochemistry modeling, using Mike, for instance, as a commercial software package, but as well using non-commercial software developed by DOE. And we do a lot of field work, both hydrological measurements. We have a drone, so we go out, take samples, etc. So because I'm fairly new to Florida, I would really like to reach out to all of you guys. And we're trying to migrate some of our work here towards Florida, as we think that our solutions can actually be potentially of interest here. So if you like what you're reading here in front of you, climate change, eutrophication, groundwater, surface water interaction, and like to reach out, well, you see my LinkedIn profile over there. So please reach out, as I'm really interested in obtaining a network in Florida around the area of water, whether it's through collaborative projects or just through a shared interested discussion. I'd be very interested in that. So thank you very much, and I'll pass it on to the next person. Thanks.
Hello. Good morning, everyone. I'm not sure if you can see me, but my name is Remy Du. I am an assistant professor at Florida International University. And here I work with a team looking at informal science learning experiences between children and their parents that occur in the home. And a lot of my focus is on how the public receives and interprets and incorporates scientific information that they encounter, and how that makes, how that influences the decisions that they make. A lot of this is in the space of science communication, and I work with a graduate student named Brenda Guerrero, who you might hear from in a little while, who's working in particular on supporting water scientists who want to convey their research to public audiences, specifically Hispanic or Latino communities in South Florida. And our work is really to support the scientists who are doing this research, who care about doing outreach and public engagement, as I see many of you do. And our interest is really right now on getting to understand the challenges that water scientists face. In particular, we recognize the perhaps lack of incentivization that occurs at different institutions, as well as the disconnect between the scientists' kinds of frameworks and ways of thinking and communicating versus the public, who is less familiar with the content. And so our goal is really to think about what are those challenges, like more specifically, what are the mechanisms across those challenges, and invite scientists to come and share their stories with us, and invite scientists to share their successes in engaging with the public, as well as the challenges that they have faced. And ultimately, our goal is to support the exchange of knowledge between water scientists and the public, and specifically around those kinds of issues and topics that relate to whether they are policy issues or socio-scientific issues that affect people's everyday experiences. And so if you're interested, you're more than welcome to contact us. We'd love to hear from you and get a sense of what your work in engaging the public has been in the past, and what are the kinds of structures that would support you continuing that work and expanding the reach of your research. Thank you.
Hello, everybody. I hope you hear me well. My name is Roshan Abbaso. I come from Azerbaijan as a visiting scholar to Florida State University. My visit here is a part of University Administration Support Program. And my research area is related to hydrology and integrated water resources management, climate change, and the climate change shifted water management issues, prevention of water losses, and prevention of climate change induced problems. My country, Azerbaijan, it's a downstream country located in lower reaches of the Kura River. Unfortunately, most of the problems related to Azerbaijan's water management cannot be solved within the boundaries of the Azerbaijan, because of the 70% of the total water resources comes from neighboring countries, and we are really negatively shaped in water management issues of our upstream countries. That's why Azerbaijan tries to solve to this kind of problems through its water governance and national adaptation programs. Currently, I am a consultant at Climate Change Adaptation Program, which take into account main directions: agriculture, water management, and coastal management. And I'm also head of the freshwater evaluation group of the National Ecosystem Assessment funded by International Panel on Biodiversity and Ecosystem Assessment, which is based in Bonn, Germany. So this is the main information. The goal of the Climate Change Adaptation Program is reduce water stress in a country. We have just conducted a study water future scenarios for Azerbaijan, and Azerbaijan will be heavily water stressed country by 2040. And our goal is to reduce water use and water losses in Azerbaijan in agricultural sector. More than 50% of total Azerbaijan's water withdrawals is lost due to poor management of water facilities and outdated irrigation methods. In National Ecosystem Assessment, we make evaluation of freshwater bodies. We put face-to-face long-term gains to short-term impacts, and our river sources, lakes has not only use values, but also great non-use values which can be transferred into the future generations. And that's all I can give you very short info. I could give you very short information. If you have any questions, you are very welcome. Thank you very much.
Sonny, I can see you here in the participant list. If you want to unmute and go ahead and present.
Hi, my name is Tom Greenhalgh. I recently retired from the Florida Geological Survey, and my interest really is three-dimensional flow in Florida and aquifer and contamination issues and water quality. As you can read from the slide, I focused for a long time on the stuff in the Swanee Basin, conducted dye traces, and used some thermography to identify springs in Taylor County coast. I would really like to learn how to acquire funding. What happened was here at FSU, I was allowed to try to resurrect a car center at the Geofluids Physical Dynamics Institute. So that's what I would like to try to do. I have one current project that's coming up. We'll be sampling for emerging contaminants in injected water at ASR sites. And that's it. I look forward to collaborating with some of you folks. All right, thanks, bye.
Good morning. We've been meeting a tremendous number of impressive scholars through this process. Really learning a lot. Thank you so much for this opportunity. Uzi Baram, professor of anthropology at New College of Florida. And it seems like I'm the only anthropologist here, maybe one of the few social scientists. And so I really am hopeful that I can get some collaboration, because as we all know, the challenges facing Florida right now are, especially with rising sea levels, are social concern. Right? We have water coming at us from the coast, from the skies, and from the aquifer. As an archaeologist, and there's a meme that lays this out. Ask an archaeologist about climate change. We have thousands of years of experience. It's a cute meme, but it also is quite accurate that there's a tremendous amount of knowledge from the past about how humans have adapted and maladapted to challenges similar to what we're facing now. But as we think about what we've gained from archaeological research, the archaeologists of Florida are all very much aware that we're losing all of the coastal sites, and they will be lost, inundated, and mostly destroyed, and we won't even know what we've lost. And so my interest is very much on the social uses of the seas over the decades, centuries, millennia, as an archaeologist, thinking both in terms of short, medium, and long term, to be able to disseminate the archaeological insights into climate change for both academic and public audiences, and to use that not for any sort of gloom and doom approach, but really the heritage that comes from the archaeological record, from the historic information, to help build up heritage for community resilience. some of my interest and expertise is on heritage interpretation, archaeological research. As an anthropologist, also engaged with ethnographic research, community engagement, and program development. Currently, been working with some biologists at New College of Florida and trying to see what else we can find beyond a simple, it's on the coast and the water's coming closer, to see if there's other indicators of dangers towards these sites, to be able to help strategize levels of significance and when we need to work on documentation, preservation, and then loss. So I'm hoping to be able to collaborate on the social impacts of the solutions many of you are offering, but also to offer the insights, the anthropological insights from ancestors, elders, and current communities. And I look forward to hearing from some of you and to work through some projects, both for where I am on the Florida Gulf Coast and elsewhere. So thank you so much, and I look forward to listening to the last few presenters.
Well, that was our final presentation for this morning. I want to thank everyone who participated today, especially our research profile presenters. We really appreciate you taking the time to give us the information to help us make these slides, and then coming out this morning to network with your colleagues across the state. Following this morning's program, we will be sharing a copy of these slides with everyone who is registered, along with a link to the presentation's recording, a list of potential funding opportunities related to water, and the contact information for the research development offices at each institution in Florida. We'd highly encourage you to reach out to these research development offices to help facilitate conversations about collaborations with this morning's presenters, and to learn more about the ways in which research development staff can help further your research goals. Before we move on to the breakout rooms to discuss potential opportunities with our keynote speakers, I do want to take a moment to thank everybody who helped make Collaborate Florida possible. These individuals have put an incredible amount of time over the last 6 months to help develop the concepts, put together the marketing materials and the event descriptions, recruit and coordinate with our guest speakers, advertise to all the institutions, put together all the research slides from today's presentation. There was a lot of effort that went into this, and I cannot say enough how much their hard work has meant to Florida, and I'm really looking forward to working with them again to develop our next Collaborate Florida event.